We continue Unit 14, Graphing Rational Functions, with Sketching Rational Functions. Here are some handy tips to sketch a rational function. The first thing we want to look for is the domain. We set the denominator equal to 0 and solve for x. So the domain is all real numbers, but x cannot equal 1. We cannot divide by 0 in the denominator, and when we put 1 back in, 1 minus 1 is 0. The vertical asymptote, we also set the denominator equal to 0 and solve. So the vertical asymptote is x equals 1. The horizontal asymptote, we look at the degrees. So the degree of the numerator is a 1. The degree in the denominator, the highest power degree in the denominator, is also a 1. Remember, when the degree of the highest power in the numerator is equal to the degree in the highest power of the denominator, then your horizontal asymptote is equal to the leading coefficient over the leading coefficient. The leading coefficient in the numerator is 1, and the leading coefficient in the denominator is also a 1. 1 divided by 1 is 1. So the horizontal asymptote is y equals 1. For the x-intercept, we want to set the top, or the numerator, equal to 0 and solve for x. So the x-intercept is negative 2, 0. For the y-intercept, remember we just let x equal to 0 and solve for y. So the y-intercept is 0, negative 2. So let's plot what we know about this graph so far. The vertical asymptote is at x equals 1. Be sure to label your x and y axis. The horizontal asymptote is at y equals 1. We know 2 points. We know that the x-intercept is negative 2, 0, and the y-intercept is 0, negative 2. We also know that there must be one and only one piece of graph in each vertical section. So when I drew the vertical asymptote, I knew at this point that this section is holding one piece of the graph. And I know on the right-hand side, we also have one piece of the graph. Remember, the notes also say that it will approach all asymptotes, but never crossing the vertical asymptotes. So that means this graph must go this direction, go through this point, and come down close to the vertical asymptote in that direction. But I also have a piece of the graph in this section. So how will I know exactly where it's at? It should be in quadrant 1, but we want to verify. So to do this, let's just pick a point to the right of 1. Let's say the next nice point over is 2. And let's do some scratch work. Now the original equation again was x plus 2 divided by x minus 1. So let's find an ordered pair that would give us a point in this quadrant. So choosing 2, if I plug 2 in for x, we get 4. So when x is 2, y is 4. So it's going to be up here, and this graph will go this way. So in the piece on the left side of the vertical asymptote, it passes through the points, so it's below the horizontal asymptote. So on the right-hand side of the vertical asymptote, there were no points on this side. We already knew that the point would be up here, so it's above the x-axis. We pick an x value and find a point to give us a better idea of where it's located. Now let's sketch the function 3 over x plus 2. First, let's get our domain by setting the bottom equal to 0. The domain is all real numbers, except where x is equal to negative 2. The vertical asymptote is x equals negative 2, because we do the same thing. We set the bottom equal to 0 to find it. The horizontal asymptote, we use the degrees. So the degree of the highest power in the numerator is a 0. Remember, the exponent on the x in the numerator would be a 0. The highest power of the degree in the denominator is a 1. 0 is less than 1, so the horizontal asymptote is y equals 0. For the x-intercept, we set the top equal to 0. So there's no x-intercept. For the y-intercept, again, we let x equal 0 and solve for y. So the y-intercept is 0 and 3 over 2, which is the same thing as 1 1/2. Let's draw our vertical asymptote first. This is x equals -2. Label the x and y axis. This means I have a piece of the graph on this side, and I have a piece on the graph on the right-hand side of the vertical asymptote. We also know the horizontal asymptote is y equals 0, and the y-intercept is 0 up 1 1/2. Now we know that the graph will flatten out towards both asymptotes, so this graph will get closer this way and get closer to the horizontal asymptote this way. As our x values get bigger, our graph will get closer and closer to the horizontal asymptote. As the y values get bigger, our graph will get closer to the vertical asymptote. But I don't know what my point is over here, so let's just plug it in a value. Not sure of the points on this side, but we do know a piece goes on this side. If this is -1, this is -2, let's plug in -3. So when I go out -3 units, I will go down 3 units, and there's my point. So the line will get closer to the horizontal asymptote and closer to the vertical asymptote. So we had one piece on this side, we had one piece on the right side of the vertical asymptote. We weren't sure where it was, so we plugged in an x value to find a point. Now let's sketch the function x squared divided by x minus 1. To get the domain, we set the bottom equal to 0. The domain is all real numbers. However, x cannot be equal to 1. To get the vertical asymptote, we do the same thing and set the bottom equal to 0. So the vertical asymptote is equal to 1. The horizontal asymptote, we look at the degrees. The highest degree in the numerator is a 2. The highest degree in the denominator is a 1. 2 is greater than 1, so there is no horizontal asymptote. And in fact, this asymptote will slant. For the x-intercept, we set the top equal to 0. So x squared equals 0, and we solve for x. So take the square root of both sides. X is equal to 0. So the x-intercept is 0, 0. Y-intercept. Let x be equal to 0 and solve for y. So 0 squared divided by 0 minus 1 is 0 over -1, which is 0. So the y-intercept is 0, 0. Let's sketch what we know. We know the vertical asymptote is at x equals 1. Label the x and the y-axis. There is no horizontal asymptote, so we do have a slanted asymptote. I know at this point that I have one piece of the graph on this side, and I have another piece on the right side of the vertical asymptote. We're not sure about point, so we're going to pick a value for x and find y. I know the x-intercept is at 0, 0, and the y-intercept is at 0, 0, but this is not going to help me, so I do need to find those points. So over here, I'm going to do some scratch work on my paper. I know for sure the x and y-intercept. I need to pick some points on either side to get a direction of this graph, because it can do this, it can do this, it can do that, it can do lots of things. So I need to pick some points that will give me an idea of how this graph is going to look. Since this is 1, I'm going to pick a point in between 0 and 1, so 0.5 will work, and -1 will be a nice point to use. On the right-hand side of the vertical asymptote, I might choose a 2, 3, and 4, or 1.5. So let's start on the left-hand side and plug in a -1 into the original equation. The original equation is x squared over x minus 1. So the original equation, I'm going to use the point -1 first. So -1 squared over -1 minus 1. So this is 1 over -2, so it's -0.5. So when I go out -1, I'm going down 0.5. So I know this graph is doing this, making this movement. On the right-hand side, this graph can either go up towards the vertical asymptote or it can go down towards the vertical asymptote. So I need to plug in some points to figure out which direction it's going to head. So I'm going to plug in 0.5. So 0.5 squared over 0.5 minus 1. I really only need, if it's positive or negative, to figure out which direction it's going. 0.5 squared is positive, and 0.5 minus 1 is negative 0.5, so this bottom is negative. Positive divided by negative will get me a negative. That means this picture is actually going down this way towards the vertical asymptote. Now I know I also have a piece on the right hand side of the vertical asymptote, so I'm going to choose some points. So this is going up this way. So we could see that our graph will have a slanted asymptote. Now let's sketch the function x over x squared minus 1. We want to factor first. So I have x on top. This is a difference of two squares. To find the domain and the vertical asymptote, we set the bottom equal to 0, and x is equal to positive 1. So the domain is all real numbers, but x is not equal to -1 or 1. The vertical asymptotes are x equals -1 and x equals 1. To get the horizontal asymptote, we look at the degrees. The degree of the highest power in the numerator is a 1. The degree of the highest power in the denominator is a 2. 1 is less than 2. So the horizontal asymptote is y equals 0. For the x-intercept, we set the top equal to 0 and solve for x. The x-intercept is 0, 0. The y-intercept, we let x equal 0 and solve for y. So the y-intercept is 0, 0. Let's draw the vertical asymptotes and label our x and y axis. So that means that I have a piece of the graph in this vertical section, I have a piece of the graph in this vertical section, and I have a piece in this vertical section. Now let's plot the point that we do know. We know the x and y intercept is at the origin. That means I have 3 pieces and I have no points. And we're not sure about any points except this one. So what we're going to do is pick some points. Okay, I know this line is -1, so a point in between 0 and -1 would be -0.5, and a point between 0 and 1 would be 0.5, so that will take care of this section. On this section, if this is 1, maybe -2, and on this section, since this is a -1, I'm going to choose -2. And since this line, vertical asymptote, is 1, I'm going to choose a +2. So I'm going to start plugging in points. I just need to see basically if they're below or above so that I can draw the line. So at -2, I'm going down -2/3. So this graph will get close to the horizontal asymptote that way and the vertical going down this way. Let's plug in +2. Obviously this is going to give me a positive number, so it's above. So at 2 up 2/3, and I know this graph is going to get closer to the vertical and horizontal asymptotes in both directions. And now let's look at the middle 2 points. So when I plug in -0.5, we get a negative on top and a negative on bottom. So the negative divided by negative is positive. That means this piece of the graph is going up. But I still do not know if my graph is going this direction or this direction. So let's choose another point, 0.5. I have a positive on top and a negative on bottom, which will give me a negative. So that piece will be drawn down. We do know that this middle piece can cross the horizontal asymptote.